This is exam 1, part 2, and I am going to talk first about the medical study where patients who ate fast food were shown to have higher heart rates than the average person. And the problem with this study is that we don't know for sure that it was actually a randomized experiment. And that's pretty important if we're going to apply any kind of causation, because an association between people eating fast food and people having higher heart rates does not necessarily mean that one causes the other. There's a lot of other variables in play there, and there's a lot of confounding and lurking variables that could be interfering with our evidence in that case. And so I think the slippery evidence in this case is just the way that the data is presented, because there's not an actual comparison in terms of the number of times the heartbeats per minute for the average person versus someone who eats a lot of fast food. And I think we don't know also the quality of the data that we're given. In terms of how slippery evidence can interfere with human inference as a whole, we will not always necessarily make correct inferences. As humans, we make mistakes, but if we're basing our inferences off of data that's incorrect or that's presented to us in a really confusing way, then we are even more likely to make errors when we make inferences. So in this case, if we are assuming that if we're going to base our assumption that fast food causes heart disease off of this evidence, well, if we don't know the quality of the evidence, then that's a pretty strong claim for us to make. And if in the case of the second scientist, his experiment cannot be used to imply any kind of causation because it was not a randomized experiment. Because the subjects were allowed to choose whether or not they ate fast food, that brings a ton of other lurking variables and confounding into the picture. And so we certainly could not imply any kind of causation regardless of whether there is an association between eating fast food and the development of heart disease. Correlation is the straight line association between two variables. Causation explains correlation. It explains the relationship between two variables. And the correlation coefficient, or R, is a number between -1 and 1, and it's a numerical expression of the strength and direction of the relationship between two variables. So you have a negative association, which would be where R equals -1, and that is when you have a line that is up to the left. Then you have no association, which, as you can see, there's just no clear relationship between these two variables, and so R equals 0. Positive association is a line that is up and to the right, and R equals 1. Correlation and causation can certainly be related. For example, one example of correlation and causation being the same would be the amount of rain in the forecast and the number of people carrying umbrellas. One good example of variables that might be correlated but not actually caused one by the other would be the number of violent crimes and ice cream sales, because the lurking variable in that case would be heat, so the two variables could very well be associated, because as it gets warmer outside, more people are eating ice cream, But as it gets warmer outside, more people are also kind of milling around and are not in school or just generally are outside and interacting with more people, and so there are more violent crimes. A huge part of slippery evidence is understanding the difference between correlation and causation, because slippery evidence can simply be assuming that there is causation when there's actually only a correlation. And the reason that we cannot assume causation just because of correlation is because there are a whole host of lurking variables that can be causing confounding with the data that we're given. So we have to be really careful when we look at evidence that it's not slippery evidence and that we aren't inferring and making conclusions about causation just because of correlation. Thanks for listening. Good luck grading all the exams.